Hey guys, welcome back. Houston Math Prep here. In this video, we're going to look some more at domain and range. So remember, the set of all possible input or x values is what we call the domain, and the set of all possible output or y values is called the range. So getting this information from a graph, let's look at an example here. So if we are working with this line graph here, if I want to find my domain, I want to look at what x values are possible to obtain from this graph. So I'm going to start from the left, and I'm going to find the first x value on the left that I can reach. And it looks like I can get all the way over to -2. I have a solid dot there, which means -2 is included. Continuing and following my graph as far to the right as I can go, it looks like I can get close to or almost reach 4. But I have an open circle, which means 4 is not included. So the way that I can write that is I can say that I can get all values from -2 up to 4. Now we're going to use some interval notation here, and the way that we express interval notation, a solid dot or a value that is included in our set, is we use a bracket. So that bracket indicates that -2 is included in our interval or in our set. 4, we have an open circle. So we actually cannot reach the x value of 4. We can only get really close to it. So the way that we indicate that is we use a parenthesis. Okay? So this is interval notation. There's also another notation that we could use, which is called set notation. So another way of expressing this is to use our curly brackets and say, we are looking for all x values such that, and then we can use inequality notation here. So we can say we're looking for x values that are between -2 and 4. Now -2 we're able to equal, so we're going to say x is greater than or equal to -2. 4 we're not able to equal, so we're going to say x is less than 4, and then close our set notation. Now, you do not have to list both unless your problem that you're working with specifies. It's an either-or type scenario. Okay, doing the same thing for range, instead of moving from left to right, we're going to move from bottom to top. So moving from bottom to top, I'm going to look at what's the lowest y value that I can reach. In this case, -4, even though it is not included, to the most top y value that I can reach. In this case, 5. So again, I move from bottom to top, or least to greatest, and I again can give my answer an interval notation. So that would be -4 to 5. -4 has an open circle, so I'm again going to use a parenthesis to indicate it is not included. And 5 has a solid circle, so it is included. I'm going to put a bracket there. Or if I want to use set notation, then the range here is the set of all y values such that y is between -4 and 5. -4 is not included, so we're going to use strictly y greater than -4. And 5 is included, so we're going to put less than or equal to there. And then close with a curly bracket. All right, there's one example of domain and range from a graph. Let's check out one more. Here's another graph that we can use to find our domain and our range. So here, one thing that is different is that I can see that I have arrows on either side of the edge of my graph. What those arrows indicate is that our graph doesn't end at what we can see, but continues indefinitely in the direction that the arrow is pointing. So that means we're going to need to remember that on the left side of our x-axis, those values extend down towards negative infinity, and on the right side of our x-axis, those values extend up to positive infinity. Similarly, on our y-axis, values extend up to positive infinity and down to negative infinity. Okay, so thinking about our domain, domain is the list of all potential x values. So when I think about x values, I notice here that my graph goes indefinitely to the left. If I sort of follow, there are no breaks in the middle, and then I come to another arrow which tells me that my graph extends indefinitely to the right. So here, according to these arrows with no breaks in the middle, I can get all x values. So there's a couple of ways that we can write that. In interval notation, we would say we are extending from negative infinity to positive infinity. Now, negative infinity and positive infinity are ideas, not numbers, so we certainly can't include them. We will always use parentheses for those. Another way of saying that, in this case using set notation, is we can say we are looking for x values such that x is a real number. So the way that we would write that, we actually have a symbol for that. So we'll say x is an element of. So this little kind of curvy e means x is in the set of. All real numbers, or negative infinity to infinity, can be written with this kind of fancy double bar r. Okay, so x is an element of the real numbers, which just means x is any real number. You might also just write that in words. So you might say x such that x is a real number. And I'm going to abbreviate number just for space. Okay, so we can get any x value and we've got different ways that we can write that. Now let's look at our range. For our range, we know we look bottom to top. So down at the bottom, I definitely have y values that I can't reach. So it appears that my y values begin here at -4, and then they extend upward without bound. So on the upper side of my range, I am seeing that they extend up, up, up forever. So I have a starting place of -4, but I don't have an ending place on the upside. So the way that I can write that in interval notation is I can say from -4 up to positive infinity. Now, since my point on my graph here doesn't have an open circle, it is filled in, I'm going to include -4 by placing a bracket. And again, positive infinity cannot be included, so we would use a parenthesis. If we wanted to do set notation for that, we would say y, not x, oops, y such that we can either say y is greater than or equal to -4, or we could also say y such that y is between -4 and infinity. However you're more comfortable with writing that. All right, guys, that does it for this video on domain and range from graphs. We'll catch you in the next one.